All right, students, welcome to this video where we are going to cover SI units. Now, this is important. I want you to think about this. SI units, these are units of measurement that help us have a common language. Imagine you're trying to have a conversation with somebody in a completely different language. They can't understand you, you can't understand them, and quickly communication breaks down and things get frustrating. In science, we have a lot to talk about, and SI units are going to be the shared common language that help us communicate, not just here in our classroom or in the United States, but say with scientists in Australia or in India or in China. So, what are SI units and why do we call them SI units? The International System of Units is abbreviated with SI, and that actually comes from French because the French were the ones to coin the term Système International des Unités. I don't speak French, so pardon my French. But we just abbreviate that as SI. And it's been narrowed down to just 7 different quantities. If we want to describe basically any phenomenon in the universe, we can do it using the quantities of time, length, mass, electric current, thermodynamic temperature, the amount of a given substance, and luminous intensity, which is referring to brightness. Okay? Now, in this class, we are particularly going to focus on 4 of these. Okay? Those being time, length, mass, and thermodynamic temperature. Okay? And so, what are the units that we're going to use to measure those? Well, we have seconds for time, meters for length, kilograms for mass, and a unit called Kelvin, which we'll come back to in just a couple of seconds here. Let's focus on the first one for a second. Time, right? You and I know that if we want to tell time, we just look at a clock, okay? Seconds can be further multiplied into greater orders of magnitude. So from seconds, we can derive minutes, hours, days, years, and so on, okay? On the opposite side, seconds can also be subdivided into, say, milliseconds, which would be 1/1000th of a second, okay? Meters help us measure length and the other dimensions of our 3 dimensions, so height and width, okay? So meters can be extended into kilometers, which would be 1,000 meters, okay? Or we can subdivide meters into, I'm sure you've heard of centimeters, or even millimeters. Millimeters would be 1/1000th of a meter, and centimeters would be 1/100th of a meter, okay? Now, kilograms helps us measure mass, okay? The mass of a substance. So kilograms can be subdivided into grams, even micrograms, okay? Which would be 1/1,000,000th of a gram, okay? A really small unit of mass. And we will, as I said, come back to Kelvin in just a moment. So let's talk about the type of tool that we would use to measure each of these quantities. Okay, for time, we could just use a watch or a clock. For length, we might use a meter stick or a ruler. For mass, we could use a scale. And to measure thermodynamic temperature, we could use a thermometer. So let's talk about temperature really quickly. That's the last unit that we haven't talked about yet. Got here a comparison of 3 different scales that can be used to measure temperature, okay? Why do we have 3 different scales? Well, I'm not going to go into that right now, but I will point out you are probably most familiar with the Fahrenheit scale. That is if you grew up in the United States, okay? And Kelvin is right here on the left-hand side, and you'll notice that the Kelvin scale is actually built or based around this idea of absolute zero. Absolute zero is theoretically the coldest temperature that matter can ever achieve. Okay, and I say theoretically because it's posited that matter has never actually gotten as cold as absolute zero, but it's gotten close, perhaps 1 degree Kelvin. Okay, and then from there, Kelvin only increases the temperature. Okay, so water would freeze at 273.15 degrees Kelvin, boils at 373 degrees Kelvin, and the temperature only goes up. You'll notice that in Kelvin, we have no negative numbers. Okay. In our class, however, we're not going to use Kelvin. We are going to use the much more popular Celsius. Okay, Celsius is used virtually worldwide with the exception of the United States and a few other places. Okay, Celsius and Kelvin are often both used by scientists to talk about studies and experiments, but in our class we're going to use Celsius. Celsius is very handy because you will notice that it is built around water temperatures. So on the Celsius scale, it has been set up so that 0 degrees Celsius is equal to the temperature at which water freezes, and 100 degrees Celsius is equal to the temperature at which water boils. Okay, from there we can go down negatively all the way to minus 273.15 degrees Celsius, and that is equal to absolute zero. Okay, that concept of the coldest temperature that matter can be or could possibly or theoretically achieve. And of course we can reach temperatures far above 100 degrees Celsius as well. Okay, so those are the 4 units that you should be familiar with. To recap again, that is time, which is measured in seconds as the base unit, length in meters, mass in kilograms, and temperature, which we are going to focus on Celsius, okay, the Celsius scale. So I hope that's been helpful, and we will see you in the next video.